All right, this set of notes will be page 53, Basic Trig Ratios. So turn to page 53 in your notes. All right, so we have learned so far that we want to use trig ratios to find missing side lengths when we have a right triangle. So make yourself a note somewhere. I've tucked that note in off to the side to give me a little bit more room. So that's when we're going to use our basic trig ratios. We have 3 ratios, and remember that we use the acronym or mnemonic SOHCAHTOA to help us remember our trig ratios. The SO stands for sine, which is opposite over hypotenuse. The CA stands for cosine, which is adjacent side over hypotenuse. And the TOA stands for tangent, or opposite over adjacent side. And I've gone ahead and given you a reminder that we pronounce them as sine, cosine, and tangent, and that they are abbreviated into 3 letters for each of them. But that's the reason that they are pronounced the way they are, because sine and cosine are both abbreviations. All right, let's remember that when we are talking about our trig ratios, we're always talking about a right triangle. And when we have that right triangle, we are always referring to a reference angle. So our sides are always in reference to that angle. I personally always start with my hypotenuse, and some people like to remember the hypotenuse by turning that right angle symbol into an arrow, and that arrow will always point to your hypotenuse. The adjacent side is the side that is always touching your reference angle. So if you have a side that is touching the reference angle, that has to be your adjacent side. And the opposite side is always across from or opposite your reference angle. Those are how you can tell when you're setting up. All right, so let's do some example problems of how we're going to use our trig ratios. Okay, so example 1, we have a right triangle. We've got a 40-degree angle, and the very first thing that I want you to do is label the sides that you have. So this 23, if I draw in my arrow, I know that that has to be the hypotenuse. And if I draw in the side that is labeled X, that has to be my adjacent side because it is touching the 40-degree angle. I prefer to make a list of the things that I know. So we remember that we always use theta to describe the angle that we have. So the Greek letter theta represents our angle. So in this example, our theta is 40 degrees. We have our adjacent side is of the X we are looking for, and our hypotenuse is 23, excuse me. So looking at the things that we have or want to know, we have the hypotenuse and we want to know the adjacent side. So if we come back up and we look at our SOHCAHTOA, sine doesn't do us any good because we don't know or want to know the opposite side. But cosine uses the adjacent and the hypotenuse. So that's how we're going to decide that in this problem we will use cosine. So we will set that up as cosine, and then our degree always comes next. So cosine of 40 degrees equals, cosine is adjacent over hypotenuse, so our adjacent side is our x over the hypotenuse is 23. If we write our cosine as cosine over 1, then it will help us remember that we are going to solve this like a proportion, and so we can cross multiply. And we end up with 23 times the cosine of 40 equals 1 times x, or just x. So then if you were to type that in, let's go ahead and type that into our calculator. So I'm going to start by typing in the 23 times the cosine of 40 degrees. And I have two ways that I can handle this so that I can get a decimal. I can either hit Control Enter, or I can just put a decimal after one of the numbers in my problem, and that will tell the calculator that I want a decimal answer. And so here it's telling us 17.619, and I'm going to round that to 17.6. So x equals 17.6. Alright, so let's look at our second example problem. In this problem, we have our reference angle is 20 degrees. We're going to go ahead and label our hypotenuse, although we don't know anything about it, and it's not the x that we're looking for. The side we are looking for is next to our reference angle, so that's our adjacent side. And across from our reference angle is 8, and so that's our opposite side. So if we come back up, and we look at our trig ratios, we didn't make our list, so sorry. So we have our theta is 20 degrees. The x, the thing we're looking for, is our adjacent side, and we also know our opposite side. So the two sides that we're concerned with in this problem are the A and the O. So we come back up and look at our SOHCAHTOA. We know that tangent is the ratio that uses the O and the A. So if we come back, we're going to write our equation. So tangent of our reference angle 20 equals, tangent is opposite over adjacent. So the opposite is 8, and the adjacent side is our x. And remember, we're going to write this as if it's a proportion so we can cross multiply. So when I multiply this, I end up with x times tangent of 20 equals 1 times 8, or 8. To get x all by itself, I have to divide by the tangent of 20. We have to divide both sides by the tangent of 20. So tangent of 20 divided by tangent of 20 is just 1. So we are going to be left with 1x equals, and then we're going to type in into our calculator we have 8 divided by the tangent of 20 degrees, and I'm going to go ahead and put that decimal in so I know to get, the calculator knows I want a decimal answer, and it has given us 21.979, and so if we were to round that, that 7 is going to push that 9 up to a 10, which then becomes 22.0. So we're going to round that to 22.0. And that is how you use your basic trig ratios.